So starting back up with number 5, we are still in polar form and we're still going to change to rectangular, so we're looking for just to have x's and y's. So this one actually has r and it has theta. So remember, if it was r and theta both, you want to use one of the bottom equations because these don't both have r and theta. So, and I said if we have trig functions, especially like cosine, sine, or secant and cosecant, you want to fix those. So what I'm going to do is I want to change cosine. We know that cosine is x over r, and then minus 5, and I'm going to change sine, and we know sine is y over r. So from here, it kind of works out like number 2. So because I have that r in the denominator, I want to multiply both sides by r. So I'm multiplying this whole side by the r. So that will give me r squared on the left-hand side. On the right-hand side, these r's will cancel out with the r that we have there. So we'll have 2x minus 5y. So on the right-hand side, x's and y's are good. On the left-hand side, we have r squared. Well, we know that r squared is equal to x squared plus y squared, so we're going to replace that. Okay, very similar to the other problems that we've seen. So we do have all x's and y's, which is correct. But I'm going to combine everything to one side so I can complete the squares, so I can see like what kind of conic section that we're talking about here. So I'm going to move over my minus 2x. I'm going to go ahead and leave a blank there. Then I'm going to have my plus y squared. I'm going to move over my 5y, have a blank. There will be nothing on the right hand side, but we're going to need our 2 blanks. So for completing the square, remember it's b over 2 squared. So for x's, the b is negative 2. So negative 2 over 2 squared. Make sure you put it on the other side. For y's, the b is 5. So 5 over 2 squared. Make sure you put it on the other side. Okay, so we can just clean this up. So for my x's, my perfect square, remember the shortcut, you can just solve the inside part, b over 2 to get the inside, so it's going to be x minus 1 squared. Plus, for my y's, 5 over 2, so we can just put plus 5 over 2. And then on the right side, we need to simplify all this out. So negative 2 divided by 2 is negative 1. Negative 1 squared is just 1. This is going to be 5 squared, so 25 over 4. So if we add common denominators, this will be 29 over 4. So as you can see here, this is in standard form now in our rectangular form. This is the circle. From our circle, we can get lots of things. The center would be positive 1, negative 5 over 2. The radius would be the square root of 29 over 4. So you could get that information. So that is how you go from polar to rectangular. So you're going from r's and thetas to x's and y's. A lot of the times, if you start out with a trig function, whether it be cosine or sine, even secant and cosecant, you're going to end up simplifying at the end, and it may end up being a circle for most of those, okay? So if you just kind of look at the patterns, the problems always follow the same patterns over and over. So those 5 examples kind of give you exactly what you need to know, pattern-wise. So that was going from polar to rectangular. So now we're going to switch gears, and we're going to be changing from rectangular to polar. So rectangular here for the first one. And when we finish, we should have r and theta in our answer. So looking back at your equation, so personally I think going from your rectangular to polar is a whole lot easier because you're going to follow the exact same steps every single time. So what you want to do is anytime you see an x by itself, like we have here with the 2x, you're always going to use this formula r cosine theta. So I'm going to replace this x with 2 times r cosine theta equals. Anytime you see x squared plus y squared grouped together, guess what that's going to equal? R squared. So you're going to replace this. Your goal for polar, you're either going to solve for r or you're going to solve for r squared. It will just depend on the type of problem, and we'll kind of see when we get to that point like why. So here it is solve for r squared, but we already have another r here, so this, to simplify, we really need to divide by r. So these will cancel, so I end up with 2 cosine theta equals r. And that, if you want to rewrite it the other way, you can. But that is our polar form, 2 cosine theta. And that's it. So we take a look at number 2. We have y equals 10 divided by x. Okay, so like I said, anytime you're going from rectangular to polar, you're just using these formulas. So anytime you see a y, you want to replace it with r sine theta. We just have a 10. Anytime you see an x, you want to replace it with r cosine theta. So just to clean this up, I'm going to cross multiply here and make this, since we have r times r, that'll be r squared sine theta cosine theta. And then we'll just have 10 on the other side. Okay, so remember, you're either trying to solve for r or r squared. We're going to solve for r squared here because we don't have another r. So if I do r squared, it would be 10 on top divided by sine theta cosine theta. This is the case where you want to just solve for r squared. You don't want to take a square root or anything here. So just kind of use that as your what I'm supposed to do. So if you would have to take the square root, then just leave it as r squared. So this answer is correct, but there is a better answer. So we can actually simplify this. So we know that if you do 1 divided by sine, the reciprocal of that would be cosecant. So instead of sine in the denominator here, I could do 10 cosecant theta. And then we know 1 over cosine is secant theta. So this would be the best way to write this answer. Okay. So anytime you have a denominator where there are 2 trig functions and they have to be combined by multiplication in the middle, you can rewrite them and move them to the top there. That would be the best way to do that. Alright, so we just have 2 more. So for number 3, we have 3x plus 12y equals 6. Okay? Same exact steps. We're going to replace this x with r cosine theta. We have 12. We're going to replace the y with our r sine theta. And it's equal to 6. Okay? The first part was the same. Second part, I'm going to think about factoring out here. So I'm going to factor out this r. You technically could factor out the GCF there, but there won't always be a GCF, so I'm just going to do the r so you'll see what you're going to do later. So we have 3 cosine theta plus 12 sine theta is equal to 6. Okay, so goal is to solve for r squared. In this case, it'll just be r because we don't have an r squared. So if we do solve here, we'll have 6 on top over 3 cosine theta plus 12 sine theta. Couple things here. Because this is addition in the middle, in the denominator here, you cannot move 1 over cosine and change it to secant, like we did on the last problem. The last problem, if you look at it again, had multiplication in the middle, so that's why you could do that. But if it's addition or subtraction, you cannot do that. So this answer is great. Perfectly fine. I will show you that there is some things where you can simplify here, but a lot of problems you won't be able to do this, so that's why I didn't do it for every time. So if we did take a GCF of 3 out on the bottom here, so really you could divide the 6 divided by 3 and you could have a 2 on top, and you could simplify it to this. So know that you can simplify it if the coefficient out front, they can go into all those, but this answer right here would have been perfectly fine. And our last problem. Okay, same kind of thing to start out with. That's why I like going from rectangular to polar, because you follow the same steps every single time, whereas going from polar to rectangular, you have to kind of switch it up sometimes. So, replacing x with our r cosine theta, replacing y with our r sine theta, and equal to 4. So these are multiplied together, so this is technically r squared cosine theta sine theta is equal to 4. You're either solving for r squared. In this case, we'll be solving for r squared because that's what we have. So it's going to be 4 over cosine theta sine theta. Now, because these are attached by multiplication and they're not attached by addition, you can simplify. So the best answer here would be r squared equals 4. 1 over cosine would be secant theta. 1 over sine would be cosecant theta. So the best answer here would be r squared equals 4 secant theta cosecant theta. So guys, that's how you go from polar to rectangular equations. Same type of formulas we used the previous day for coordinates, but that's how you switch from equations, going from polar to rectangular or vice versa.